answer is B for this question. Okay, let's solve. Let's solve towards the answer. How we can get this B. So a student performed X-ray diffraction experiment on a FCC polycrystalline pure metal. Okay, so it's a FCC crystal structure, and sin square theta ratio is given, right? So your sin square theta ratio is given 0.136, then 0.185, then 0.504, then 0.544. This is sin square theta ratio. Then it's telling the student was negligent and missed noting one of the peaks. Which of the following indices correspond to missing peak? So that means you have to index what is your peaks here. Okay, what is the peaks here? Because for FCC, you know the peaks H square, K square, L square value. What is that? 3, 4, 3, 4, 8, 11, 12. How is that I know? 1, 4, 3, 1, 4, 3. I'm adding 1, then 4, then 3, then 1. So you can write all of them. It's a 1, 4, 3, 1, 4, 3, 1, 4, 3 repetition, or I love you repetition. Okay. So H square, K square value is 3. That means it is 1, 1, 1. Here H square, K square second peak should be 4. That means 2, 0, 0. H square, K square, L square is 2, 0, 0. Then 8. 8 means third should be 2, 2, 0. Then fourth should be 11. That means 3, 3 is a 9 and 2. That means 3, 1, 1. And fifth will be 12. That means 2, 2, 2 square plus 2 square plus 2 square. 4 plus 4 plus 4. That means 2, 2, 2. Right? Because it is FCC, okay, the peaks HKL will be 1, 1, 2, 0, 0, 2, 2, 0, 3, 1, 1, and that 2, 2, 1, right? This is what you should get because you know it is FCC. But students get this ratio. He missed one of the sin square theta values somewhere, here or here or here or here. We don't know. Somewhere he missed. Okay, you have to find it. So this is the very basic activity I ask my students to do. If you know your 2 theta value, how to know your HKL value? If you know the structure, or if you know your 2 theta value, can you find which structure is this? So what we do, we convert this sin square theta value. If you know 2 theta value, we find sin square theta value. Then we convert this sin square theta value into H square plus K square plus L square ratio. This one, and then we find the HKL. Okay, it's very simple activities that we ask our student to do. So how to go from sin square 2 theta value, sin square theta value to H square, K square, L square value? Because if you know this, we know, let's say it will come 3 here and this 4 here, then 3, 4, 8 here and 11 here. Then we know what is my HKL value. If I'm getting this ratio 3, 4, 8, 11, then I know it is 1, 1, 1, 2, 0, 0, 2, 2, 0, and it is FCC structure. Okay, so major task is to find out H square, K square, L square ratio. How to find out? So the basic idea is simple. The basic idea is that sin square theta ratio is exactly same as H square plus K square plus L square theta ratio. Means if you can find out what is the ratio in between this number 1, 2, 3, and 4 numbers, what is the ratio? You can find out the same ratio as you can take it as a H square plus K square plus L square ratio. How? So you can derive it from Bragg's law. See here, your lambda is 2D sin theta, right? I want H square, K square, L square. So lambda is 2A by root H square plus K square plus L square sin theta, right? Now I can simply write sin theta, and so your sin theta could be lambda by 2A, right? And root H square plus K square plus L square. I want H square, K square, L square, so I can square both sides. So my sin square theta is lambda by 2A H square plus K square plus L square. Can you see here? Your sin square theta is directly proportional to H square plus K square plus L square. That means the ratio of sin square theta, okay, that means your sin square theta ratio will be exactly same as H square, K square, L square ratio. Because they are directly proportional. The ratio will be same because they will have a common constant K. You can cancel it out, right? That means what is the ratio? So our major task is to find out what is the ratio between these 4 numbers. that will be exactly become, if it is exactly becoming 3, 4, 8, 11, then I know it's a FCC structure. And what is its corresponding HKL peak, right? So let's jump there. How to find out from sin square theta, how to find out h square k square L square ratio. Okay, so first I'll have to find out sin square theta ratio. How? So simplest way is, let's say I'm writing 2, 4, 8, 10, 12. This is the individual number of BCC h square k square L square. What will be h square k square L square ratio? What will be the ratio between 2, 4, 8, 10, 11? You divide the whole number, different numbers in the series by the smallest number. You divide 2 by 2, 1. 4 by divide by small number 2, 2. 8 by smallest number 2, that is 4. And 10 by smallest number 2, 5. I think 2, 4, 6 I missed. 6 by 2, 3. So ratio h square k square L square ratio for BCC is 1, 2, 3, 4. How I get this ratio? This is ratio. This is the individual number for individual peaks. So this ratio I would get, I divide all the numbers by smallest number 2. So you can do same thing here also. That is the basic idea to get the ratio. The smallest number is this. So divide the whole number, this, and this. Okay. Divide the all the sin square theta numbers, like this also, this also, this also, by 0.136. So if you divide 0.136 by itself, you'll get 1. If you divide 0.185 divided by 0.185 divided by the smallest number, 0.136, what you will get? You will simply get 1.36. If you divide 0.504 divided by 0.136, 0.504 divided by 0.136, what you will get? You'll get 3.7058. If you divide 0.544 divided by 0.136, you will get 4. Now here's the trick. I want to get FCCs. I want to get this sin square theta ratio is my h square k square L square ratio, right? I want to get this as a 3. This is 4. This is 8. This is 11. 3, 4, 8, 11, 12, right? But I want to get 3, but I am only getting 1. What is sin square theta ratio? Sin square theta ratio is the corresponding sin square theta value divided by smallest sin square theta, that is 0.136. Now I want to reach here. My first peak, I know it's FCC. My first peak is 3. How can you reach there? I will multiply this whole value. I will multiply this whole value by 3. Because if you multiply 1 by 3, you get 3. But my point, I'm intentionally making first peak as 3. If automatically this is becoming 4, this is becoming 8, this is becoming 11, then it's FCC. You got the point? So I will make first peak as 3. How? This quantity, sin square theta by 0.136. Whatever you're getting here, you're getting 1. You multiply it by 3. This by 3, 3. If you multiply this by 3, you'll get 4.08. If you multiply this by 3, you'll get 11.11. If you will multiply by this by 3, you'll get 12. So what is the nearest number, guys? You got your answer, I think. The 3. This is 4. This is 11. This is 12. 3, 4, 8, 11, 12. You are missing what? 3, 4, 8. You must have 8 here, right? That means that person has missed to note something in between here, some sin square theta value. So what is the corresponding peak? The corresponding peak is 8. This is your sin square theta ratio, right? Sin square theta ratio divided by into 3, so that I can get my 3. It is exactly same as h square plus k square plus L square ratio. I'm getting 3, 4, 11, 12. I'm missing 8 because I must have 8 in my, if it is FCC, right? 8 means which peak? Which peak? This is 3, this is 4, this is 11, 8. Which peak? 2 to 0. That means your answer is B. Okay. I hope you, so this is a basic thing. Nowadays, your answer is, let me just see. Your answer is B. Nowadays, we have got XRD, I mean the, what do you call it, expert software. Using that high score also. Using that, you can put the sin theta value, it will directly match with the database, and it will tell which structure is this and what is the material. In fact, it can calculate. But manually also you can do it by knowing the sin square theta ratio. That will be h square k square l square ratio. If it is matching with 3, 4, 8, 11, then it will be FCC. Then you can take individual theta value, and then you can take other lambda given, and you can calculate A also. And if you know A, you know which material is this, because A is well known in the database, right? So this is how manually we do. For question number 54, your answer is A. Your answer is A. I'm doing this so that one can quickly take the reference and go forward, because they have come here for answer key. Okay, let's see how answer will be A. Okay, so it's a very easy question actually. I mean, it's the simplest. I mean, the direction and the plane and the direction. So it's a question based on the Miller indices. Okay, so what is the C here? How to reach here? It's a direction. So what is the Miller index of direction? How to reach in all axes. Let's say this is my x. Okay, this is my, okay, my origin should be my this should be origin. So let me this as origin. This is my x. Let's take this as y, and this is as z. Your should be always anti-clockwise x, y, z. Okay. Now, how to reach there? I will travel half distance towards x, y, and z. Half distance towards x, and minus half distance, because this is z direction, positive z. Opposite will be negative z. So I'm traveling negative half direction towards z. So negative half, and then I'm traveling exactly one direction towards y. So this is why I can simplify it. That will be my Miller index of direction. I don't need to take ratio because it is not plane. Simply I multiply by 2, it will again 1, 2, and 1. So this is my direction. 1, 2, 1. It's very simple. Similarly, to reach here, I will travel one distance towards x, and similarly minus one distance towards z, minus one distance towards z, and half distance towards y. Half distance towards y. And what you need to do is just first draw the axis, and then you will understand what negative z and positive z means. This is why. Okay. So you simplify by 2. So 2, 1, and 2 bar. 2 and 2 bar is the for this C, for this S. Right. Now let's come to the plane. For plane, you need to not only find x, y, z, but also you have to take reciprocal and then simplify, not directly. It's a plane. Here, if you take origin this, let's take this as x, this as y, and this as z, positive z, and this is going to be negative z. Okay, so here it's cutting x at one distance, y at one distance, and z at minus one distance. Simple. You don't need to take, if you take reciprocal, it will be 1, 1, minus 1 also, and it is already simplest one. So your plane will be 1, 1, 1 bar. Here, let's take this as a origin. The x, y. I'm explaining everything. I know many of you already know this answer. You can skip the video. I'm explaining for those who have no idea at all what's happening. So I must take the student with zero knowledge in consideration. Then only everyone will be able to understand everything. So x, y, z. Okay. So it's cutting one distance in x. Similarly, minus one distance in z, and it's parallel to, as you can see here, y-axis. So infinite. Now take the reciprocal. So 1, 0, minus 1. So plane will be 1, 0, 1. As simple as that. Okay. So my q is 1, 0, 1 bar. Okay. And you can now easily match. Now for this, your answer will be D. How's that? So your Brinell will be still sphere. There is no doubt at all. Okay. So your answer could be B or D. Now your weaker will be always diamond pyramidal. It will be something like this. This is a pyramidal. It will look conical. Okay. It's a pyramidal. Pyramidal means you'll get an impression of something like this. So you have a one face here, 2 and 3 and 4. So actually, you'll have a tetrahedron pyramid. Okay, so you have a something like this. You got my point? So this is this one. Okay, and this and this and this is the 1 2 3 4 faces. It will give you impression here. Right? So if you take this length, it is L1. If you take this length, diagonal length, it is L2. Average of L1 and L2 will give you L. Now you can apply the vernal hardness, that is 1.854, and P by L square. P is your load. Okay, L is your average diagonal length. So that is why weaker will be definitely always diamond pyramidal. Right? So my P is 4 and R is 1. So P is 4 and R is, so answer is going to be D. Then your Q will be definitely 2. Okay. Don't be confused. Okay, even if you see your P is 4, it's okay, and your vernal is a diamond pyramidal, then it's solved. You don't need to think for any other. Okay, now next question. This question is really interesting, and the answer for it is C. Unfortunately, because many of you don't understand the very basic of triple T diagram. Okay, the basic thing is that what is the starting temperature of any transformation, and what is the final, what is the starting point, what is the final point, and when will you get transformation, when will you not get, if you draw any kind of path. I mean, it is so tremendously or so in excellent way explained in Callister. If you open your Callister book, it is well explained, all the roots. Okay, in the Callister itself. Okay, so I hope my students are able to solve it, because it was well explained in test series as well as in regular courses. Regular courses, it was repeatedly given in weekend tests also. Okay, so idea is simple. I know where you might have made mistake. The idea is simple. This P will is this is austenatic region. So here you see it is it touching this starting transformation temperature of, so above nose you have a perlite, below nose you have a bainite. It's as simple as that. This is the upper bainite, this region, this is lower bainite region, this is coarse perlite region, and this is fine perlite region, very close to the nose. But ultimately above nose it's perlite, below nose it's bainite. And this is the starting transformation line, this is the finishing transformation line. Anything which will touch this starting transformation line will give you the hint of its transformation is started from this phase to this phase, from this phase to this phase. Okay, a transformation must start, then only you'll get that phase. Got my point? Must start, transformation must start. Okay, that is the trick here. Now let's see here. This austenite is getting started. This austenite is getting converted into 100% perlite. So P will give you 100% perlite. So P will give you 100% perlite. P is 2. This, and this. All it could be the answer. Now, if you see the R, you're in an austenitic region, and then you start transformation. It is touching this starting line. You start transformation of bainite, and you finish also. So 100% bainite. So R will give you bainite only. So R is 1. That means this could not be the answer. It could be either one of C or D. And here is the important part. Do you understand this transformation? Okay. If you understand, so if you see here, I am in austenitic region. I start my transformation. Okay. Above what? Nose. That means, and it's exactly 50%. It's exactly intermediate line, central line. This is the 50% transformation line. This is a start line. This is finish line. This is 50% line. As you can see here, it's touching the what? It's touching the 50%. I mean, here the transformation from gamma to, because it is above nose, so gamma to perlite. So here it's touching here. So it's 50%. So gamma is converted into perlite. How much? It is touching 50% line. That means 50% perlite. So 50% gamma is transformed into 50% perlite. Remaining 50% into perlite. 50% gamma is transformed into perlite, right? The remaining 50% is still there because now you change the route. And here is the trick. Many students will think that, sir, since it is passing through this binitic region, it will also form binite. You have to understand this. To get any transformation or transformed phase, transformation must start. Is it touching this starting line anywhere like this or this or this? It is crossing starting line anywhere? No. To get that, you must have to give something like this. You have to show path like this. You have to take dotted line. You have to show this line like this. Then you have to come like this. You have to start, or you can immediately you can show like this. And this many author has shown like dotted. You have to again go touch the transformation line in a starting line, and then you have to pass. If it is touch, you have to go like this. Got my point? You must touch the start of the transformation. If your transformation is not starting, how will you get any phase? Now it's started, it's finished. So here 50% austenite is converted into perlite, and remaining 50% is started transforming into, it's a below nose, so binite. And binite transformation is finished. So rest 50% austenite will be transformed into 50% what? Binite. And here you transform 50% perlite. So to get binite, you must start like this from the starting point. If you are going here, you are not making the binite because you're not touching anywhere the start of transformation. If the transformation is not started, how will you get transformation? You got my point? This line should come like this. And then either it can also go like this. In that means here I have a 50, I start my transformation, 50% is converted. Now I again start my transformation. I got 50% transformation. So my 50% gamma is converted into perlite, remaining 50%, okay, gamma. So it's again starting transformation of binite because it is beyond below nose. Binite 50% is touching, right? 50%. So 50% of the remaining, that means half of 50%, that is 25% is converted into binite, and remaining over 25% austenite. Now again you see it's again touching the starting point of martensite transformation, and it's crossing the finishing. The remaining 50% converted into martensite. You got my point? To get binite, the transformation you cannot by passing it. You're not crossing this starting line, so you'll never get this binite. You don't think like this is passing through the binite, so you'll get binite. No. That is what I stressed in every class whenever I explained this. Yes, it is touching the initial starting transformation of martensite. So remaining 50% will transform into martensite because it is converting 50% started transformation, and then it crosses the finishing line. That is 50% is transformed here, and then 50% is whole remaining 50% gamma is transformed into 50% perlite. And the remaining is started transforming into martensite and finished. So 50% gamma, remaining gamma is transformed into martensite. You got me? You get only perlite and martensite, not binite. Many of you have chosen this 3, right? So pica perlite and Q-ka binite. So pica 2, Q-ka 1, pica 2, and what? Pica 2, right? Q-ka kya hua? Oh, R-ka 1, pica 2, pica 2, R1. So you can get pica 2 and R1 in only this situation. Pica 2, R1. You cannot take Q-ka 4. You cannot take Q-ka 3. That's wrong. You can take Q-ka 4. Okay. Okay. The same thing is explained marvelously in canister. You see, it's this question is given in 10th chapter. You can see source is given here. Okay. So There is some alloy, it's given, this is the phases available in the microstructure, like pro alpha and 58% force per light, and per light and by night, and 100% martensite and austenite. It's given. How you will show? I will show. So this is what it is shown here. As you can see here, see this line. We started the per light conversion. 50% austenite is converted to per light. Now, if it is passing through this line, that means you, even though it's passing through the binitic, it will not start binitic transformation because it is not touching the binitic transformation. It is touching the start of martensitic, and it is crossing the start of martensitic. Got my point? So if you are passing through this, you will not get binite, but you can change the route. Again, touch the crossing point, and then you cross the whole transformation. So you see here, your 50% austenite is converted because it's touching the 50% line. This is 50% line. So your gamma, 50% gamma is converted into what? It's a perlitic line. So perlite. Remaining 50% gamma, half of gamma, is again, you see, it's not going down. It's starting here. It's start the binitic transformation and remaining. It's finished. The binitic transformation is finished because it is crossing the finishing line. Finished means all the 50% is finished into what? Binite. Again, here is the trick. It will never, now even though it's going here, it will never form martensite because all 100% gamma is converted. Finished. You don't have here at this point, you don't have any gamma remaining. Then even though you're crossing this martensitic start and finish, you'll not get martensite. Got my point? There is nothing remaining in the system. How will you get martensite? Got my point? So in B, you'll get perlite and binite only. In B, you'll get perlite and binite only. Even though it's crossing the martensite. Similarly, in the previous, if you go like this, like in a question is given, it's 50% austenite is converted perlite, and it's not crossing the starting transformation starting line. So it will not start the transformation. It is crossing this martensite transformation line, so remaining will be transformed. Okay, it's a very simple logic. Once it is crossed the finishing line, there is nothing remaining. For example, here you see austenite is converted into ferrite, and then all the remaining ferrite is remaining austenite is converted into finishing perlitic. So it will be for finishing perlitic. All the gamma is if it is crossed the finishing line, all the gamma is converted into that. Even though after that you are going down, you will not get martensite because all is finished already. Some you get some amount of ferrite you will get. Some amount of ferrite you will get. This is A, na? So some amount of ferrite you will get, and the remaining it crosses the perlitic region, perlitic finish line. That means remaining will be perlitic. You won't be getting any martensite, even though you are cooling quenching very rapidly because your transformation is already converted. There is no any benefit of quenching. For 57, it's MSQ. Your answer is BCD. Okay, so here. Which of the following statement is or are true for an optical microscope? It's talking about numerical aperture and resolution, wavelength and resolution, and the refractive index and the resolution, and wavelength and depth of field. So how wavelength, refractive index, and resolution and depth of field are related? If you know the basic relation, you can easily find it out. Okay, so what is the relation? The relation is given here. Your numerical aperture is n sin alpha. Alpha is half conical angle. So for example, if you're let's say this is your sample and this is your lens. So this will be half conical angle. Okay, and so how much light it is taking is the numerical aperture. Okay. So bigger this, you will get bigger alpha. So higher the alpha, higher will be numerical aperture, and also higher the refractive index, also you'll get higher numerical aperture, right? Your diffraction limited resolution is 0.61 lambda by Na. So okay, so 0.61 lambda by Na. Na, that is nothing but 0.61 lambda by small n sin alpha. If you increase alpha, you're decreasing R. That means the smallest distance to resolve is more getting smaller. That means its resolution power is increasing. Like if one microscope is resolving this much If two entities are this much farther, then only it is able to resolve. The resolution R value is so big that means it has very poor resolution. The more closer, the smallest distance you can distinguish, okay, the better the resolution. That means smaller the R, better the resolution is. Then this R should be smaller, then only your resolution is better. You got my point? So if you increase N, your R will improve, resolution will improve. If you increase alpha, your resolution will improve. If you increase lambda, your resolution will decrease, okay, or become poor. Okay, you got my point? It is also related to magnification, so please read and note it down. It may help you. Okay, so for working distance and magnification also it is related, because your Na is related to magnification. Okay, that magnification is T by F, as you can see here. This is my sample, this is my lens, so this is my focal distance. Now if I'm making this sample, I'm taking closer, that means I'm increasing my alpha. So to increase this alpha, so that I can get better resolution, I'm actually decreasing the working distance, or I'm actually decreasing the F. If I'm decreasing the F to enhance R, I'm increasing magnification. That means you can get better resolution. In optical microscope I'm talking, not SEM. To get better resolution, your F should be low, or this working distance should be low, so that my alpha will be higher. If F should be low, then magnification should be high. So you can get better resolution at a higher magnification. That is the optical microscopes concept. So you can read this. Now let's go to the depth of field. How depth of field is related? So your depth of field is related to 1.22 lambda. So your depth of field is related to 1.22 lambda n square minus na, okay, to the power half to the power divided by na square. Normally alpha is very small, that is half conical angle. Alpha is very small, that means na will be also very close to 0. So this na will become very close to 0. So n square minus very small number is n square, and n square to the power half is nothing but n. So this whole fraction will give you n. So it is 1.22 lambda n lambda by na square. So this is the depth of field. So you can relate lambda and na square, right? Now if you notice here, your resolution, that is 0.61 lambda, 0.61 lambda, okay, 0.61 lambda by na, and your depth of field is, I'm taking the approximated one, 1.22 n lambda by na square. If you see here, by increasing na, or by increasing n, or by increasing alpha, okay, you are decreasing R, means you are improving the resolution. And here also by increasing Na, what exactly you are doing? You are decreasing the depth of field. Means you cannot improve both at the same time by disturbing the Na or increasing N or alpha. Got my point? If you increase Na, your resolution will improve. At the same time, your depth of field will decrease. So that is a lower depth of field, means you cannot get more deeper, you cannot resolve two entities at two depth. Like if you have a fractured surface, if depth of field is poor, you cannot get the peak and the valley of the fractured surface. You cannot feel the depth because depth of field is very poor. You got my point? Okay. So at high resolution and large depth of field cannot be achieved at the same time. The same thing is given here. Like large topography variation, you cannot observe. If you want to get very high resolution, then your depth of field will be compromised. Got my point? Now, if you see this, if you know these two formula, it's very easy to find this. So your resolution is, here is the trick. The trick is, you want this R to be as small as possible, then you will tell resolution is better. Because R is the smallest distance that can be distinguished between two entities or features. Smallest distance, smaller it is, better the resolution. Smaller the distance, it can resolve, better the resolution. Means smaller the R. I want a smaller R, then I will call you better. But in case of DOF, small DOF is the small DOF, poor. But here small R is the better. Got my point? Here DF is the smaller depth of field is poor the depth of field. Got my point? So here it is 1.22 n lambda by na square, or 1.22 n lambda by n square means n square sin square alpha. Now let's see the option. You can easily answer it. You will get the BCT. What is that? Increasing the aperture, increasing this, the resolution deteriorates. That's wrong. If you increase this, R will become lower and lower, that means the resolution will become better. This is not the answer. Reducing the wavelength means by reducing lambda, resolution is improved. Yes. If you decrease the lambda, your R will decrease. That means more smaller distance it can distinguish. That means better resolution is. So B is the answer. Increasing refractive index, okay, the improves the resolution. So increasing refractive index by increasing n improve the resolution. That's correct. If you increase n, it is inversely proportional. R will decrease. That means better resolution. And reducing the wavelength, since you reduce the wavelength, okay, you get better resolution. But if you reduce the wavelength, your depth of field will not be better. It will decrease. If you reduce the wavelength, what will happen? Depth of field will also decrease. Okay, it is directly proportional. So B, C, D all are answer. If you remember these two equations, it's very easy to answer any question, and it is well explained in regular course as well as test series. So I hope you all guys, if you're my student, you all are actually should be able to give answer. It's very basic question. Next, among the 14 Bravais lattices, there is no base-centered cubic unit cell. Which of the following statement is or are true? It's very basic question that is basically asked. Why a face-centered tetragonal is not possible? Because the maximum number of, in any crystal system, maximum number of Bravais lattice that you'll say it is 4. Any particular. Simplest one is primitive, body-centered, face-centered, and base-centered, or end face-centered, or base-centered. This is maximum that you get in orthorhombic. But in cubic, you get simple body and face. Got it? But this is not. This is missing. What is the reason? It will repeat some other structure. Some other. It will repeat the any age face center or base center will repeat its primitive one. I can draw and I can show you. It will repeat any base center will repeat its primitive one. But that is not the only case. That means this base centered. That means in orthorhombic, this base centered will also repeat this primitive one. But why we are writing base centered here, but we are not writing base centered cubic in cubic crystal system? But only it's not only the repeating that. Another important criteria is that if it is repeating and also showing the same characteristic, what you call it, point group or characteristic symmetry, then there is no point of writing this base centered. For cubic, if you write base centered, of course it will repeat the structure. It will become primitive. If you draw in our 3D lattice, I will draw and I'll show. Any base centered will repeat the primitive structure. So this will also repeating, but your base centered, it's repeating primitive, okay. But your base centered, is it giving you the same typical cubic characteristic symmetry? What is typical cubic symmetry? At the diagonal, it should show you threefold symmetry. Threefold symmetry. I have given you chart and table like all point group, all the characteristic symmetry for all crystal system, if you remember. Okay. So the cubic, it is threefold. Threefold. How many diagonals are there? How many axes? 4 diagonals in cubic. So 4 axes are there. So 4. How many? 4 threefold axes or 4 threefold symmetry. So you must get. So you see, in simple cubic, if base centered simple cubic is repeating primitive, you got my point? But at the same time, if it is also showing threefold axis, got my point? Then it is a different base centered cubic, because by putting 2 extra atom at the base, you understand my point? By putting 2 extra atom at the base, it will repeat this primitive structure. I'm pretty sure. You can draw another here, you can draw another here, and you can draw another here, you can draw another here, you can draw another here, and you can draw another here, and you see it will become primitive only. Every base will repeat the primitive if you join. But that base centered, if that base centered is also showing the same characteristic symmetry that your simple is showing, that means adding 2 extra atoms is not disturbing the symmetry of the cubic, then that will exist. This base centered cubic symmetry will exist because your atomic arrangement is changed, but it is maintaining the threefold symmetry. Then it will be there, it will remain. So your cubic will show you four type of Bravais lattice: simple, body, face, and base center. But what happens actually is, by adding these 2 extra atoms, even though it's repeating the structure of simple, but it is violating the fundamental threefold diagonal symmetric axis. You will never get threefold symmetric axis. That is why this base centered cannot be considered as lattice of cubic crystal system, because for becoming the criteria for being the member of cubic crystal system is that you must have characteristic symmetry, that is threefold symmetry. This base centered, you see, by adding only you can see, can you rotate this and you will get this threefold symmetry? No. If you don't have this atom, then you will definitely get. So since this base centered is not giving you threefold symmetry, even though it will repeat the primitive one, some primitive, it basically it becomes tetragonal. Some primitive, it will become primitive, but it is not following the symmetry of characteristic cubic. Then it cannot be a member of cubic crystal system. Got my point? Similarly, in what you call it, in orthorhombic, if you see orthorhombic, you have a simple, body centered, face centered, and end base centered or end face centered. This will actually repeat the primitive of some of the crystal structure. It will repeat, but it also gives you the exactly shows you the, even by adding 2 extra atoms, it repeats the same, it gives you same characteristic symmetry for orthorhombic as this all will show you. So it is a member. For if you see for tetragonal crystal system, you don't have a FCT. You have a primitive body centered tetragonal. You don't get the face centered tetragonal. This is not possible. What is the reason? And the reason is this face centered tetragonal repeats the structure of primitive, and as well it will always repeat, but it will repeat one of the member of the lattice, but it will never show you the characteristic symmetry, that is 4-fold symmetry of tetragonal. Face centered will never show you the 4-fold. By adding the atom at the face center, it will violate the symmetry, characteristic symmetry that is required for being member of tetragonal, that is 4-fold. Got my point? First position will be in point group should be 4. Okay, so it is not a member. That is the reason. Okay, remember. So it's correct that base centered cubic base centered is not possible because it will repeat the primitive of some structure. It is tetragonal actually. I will show you. But that is not the only criteria, because it is repeating. So we have already primitive tetragonal. Then why do we need extra BCC? Since you have already simple cubic, then why do we need BCT, base centered? Because it's repeating the structure of primitive tetragonal. Okay, you need unique Bravais lattice, that is only 14. You cannot get more than 14 because it is repeating some other Bravais lattice. But that is not the only criteria. You have to go one step ahead. It should violate the symmetry also. That then only you can say it cannot be member of that crystal system. Like base centered will never follow the characteristic threefold. That's why it cannot be a member of cubic crystal system. That is also one criteria. That's why we cannot put. This is one exercise that you all should do. Like your base centered, which is missing in the crystal system, the member or Bravais lattice which is missing in the crystal system, just do the exercise. It will repeat which structure. For example, this base centered cubic will repeat simple tetragonal. I will show you the exercise. So for C Tom Thur, and 32, 111. So the maximum possible is primitive, base, body centered, face centered, and base centered. But here you get only 2. Here you get a 3. Someone is missing. Which one is missing? Here you're getting a 3, like simple, body centered, face centered. You're missing body centered. Just do the exercise. See, this body centered cubic is repeating. It will repeat some primitive structure, some primitive Bravais lattice. It will repeat the tetragonal primitive. You make the exercise. Similarly, here 2 are missing. So just make them also. And then see it is repeating what. Here you see, here this monoclinic. Okay, so here it's getting 2. So another 2 is missing. Do this exercise. For example, in tetragonal, you have a simple and body-centered tetragonal. You don't get face-centered, and you don't get base-centered. Do the exercise. See, your face-centered tetragonal is repeating what? It will repeat primitive. And similarly, your base-centered will repeat what? Face-centered repeat. Okay, I will do the exercise. Your base centered will repeat primitive. Okay, so do the exercise. For example, and of course, one reason is the not following the symmetry. Okay, so its answer is A and D. Okay, so it will give the simple tetragonal. You can do the exercise. This is memory part. Okay, you might have missed this. If you know how to draw, you can easily find out. And this is the well known because it doesn't exist in your cubic crystal system. It cannot be membered because it violates the symmetry. It's very simple. Any Bravais lattice which cannot exist because it violates the basic symmetry or point group of that crystal system. For example, in tetragonal 4-fold, in body centered, it's a what you call it, a 3-fold along the diagonal. In cubic, it's 3-fold. In tetragonal, it's 4-fold. In hexagonal, it's 6-fold. Got my point? That's why you cannot have. Here you see. Let's go to this is my typical cubic. If I'm drawing bod end base center, that means I will put atoms at the end face and base center. I will put atom at end face. I will put atom at end face. Put atom at end face. Now, if you notice here, guys, you see this. It's actually repeating the unit cell of what is this structure called? Bolo. It's a primitive because atom is only at corner. And see, this is same. It is usually half of diagonal that a root 2. This is also no. A root 2 by 2. Wait. It should be same size because the tetragonal, all sides should be. This is A and this is A root 2. Okay, I cannot make the unit cell like this. Sorry, let me do undo. What I need to do is I have to join some other points. Okay, so how to join? If I remember, this. What is this length? No. If you see, yes, I can see that. I can visualize it. This you can take it as a this you can take it as this you can take it as this you can take it as this. You can join all the points. It's very basic. See, you can join all the points. You will definitely get simple tetragonal. The reason is, see, what is this length? This length is A root 2. This length is because it's half of diagonal, right? It's half of diagonal. The full diagonal is a root 2. It's a half of diagonal. It's a root 2 by 2. What is this length? This is also half of the diagonal, right? This is full diagonal. It's a half of diagonal, a root 2 by 2. This is also half of diagonal, right? It's a root 2 by 2. This is also half of diagonal, a root 2 by 2. So all a equals to b, right? And this length is no longer a. It becomes c, right? It's a greater than a, right? So you get a simple tetragonal. You got me? Similarly, please do the exercise for others also, for FCT and others, okay? And of course, one criteria, this is not the only criteria. Another criteria must be, even though it will repeat, okay? If the crystal, the basic characteristic symmetry, it's not following, okay? Since even though it's becoming the tetragonal, na, you cannot. And another reason is it's also not following the what you call it, threefold characteristic symmetry for cubic. So you cannot put this end face centered as a member of cubic crystal system. Okay. The next question, the answer is, I'm doing this answer so that one can skip. The answer is A and C. Okay. The idea is very simple. I've already explained this. Your CV is BTQ and CP is BT square. This graph I already gave to my regular students. Okay. This and of course these graphs are, this equations is for metals. And of course, those metals are 3-dimensional. We cannot imagine for nano wire that is 1D or nano film that is 2D. These experiments are done in 3D bulk material. So if you see this, CB by 2, C by T, Y, it is Y. Y equals to, it's a linear line. So Y equals to mx plus C. Your m is, and what is x? X is your t square. So then write y is my cv by t equals to m. M is m, right? Or you can take a or b, whatever, that doesn't matter. Your m, x is your t square, and plus some another constant c. Right? So actually, if you see here, let's take this as coefficient b and this as a. So you can take anything, bt square plus a. If you simplify, your cv becomes BTQ plus AT. This is what I already gave to my students, and this is for metals, for metal system, and it's for 3D. So definitely this graph, it's telling you CV equals to BTQ, third power in one power. It's for metallic and it's for 3D for sure. The actual expression, this is the symbolic expression. We have a B and A. What is the actual value of B and A? So this is well derived. Okay, you can see here. So any heat, specific heat that at constant value, that is CV, or it is thermal conductivity, in both cases, you have a contribution of both electronic and vibrational. Electronic and vibrational. Okay. Now, so electronic contribution give you with the power of T, and vibrational contribution, that is the phononic contribution or lattice vibration, will give you at the power of 3. So you can see here, this constant you can take it as A, and this constant you can take it as a B. So actually your C for metal is AT plus PTQ. Remember, it's for metal and it's for 3D. Next, the answer is 4000. The question is very basic. Okay. So you can solve it within fraction of a second. The pure silicon wafer is doped with boron by exposing this gas at elevated temperature. It takes 1000 seconds, T equals to 1000 seconds to reach boron concentration of this. So boron concentration is at particular depth, right? So CH equals to, you have a 10 power 20 atoms. So it is in atom percent, okay? Atoms, you have to convert in atom percent, then the kg per meter cube. Anyway, let's see. And depth, your x is given at x equals to 1 micrometer. The time taken to reach, okay, another times, that means it is T1. So time taken to reach the same concentration. Oh, concentration is same, diffusivity is same, and D is same. You don't need to use that fixed second law. It's a very basic question, because you can take this x1, this is T1, and this is x1, and this is T2, x2 is 2 micrometer. It's a basic, because for same concentration, for same result, diffusion result, for same diffusion result, it's also given the boron concentration of wafer surface remains constant. So everything is remains constant. For same diffusion result, that means D is same, D is constant. Okay. You can write X is directly proportional to anything which is same. Okay. A variable X1, X2, T1, T2, D1, D2. D1, D2 you can get if you change the temperature. Like T1, T2 you can do. Then also you can get D1, D2. Any if you're getting X1, X2, D1, D2, T1, T2, or for same diffusion results also, you can write X is directly proportional to D2, DT. It's very basic question, right? That means your T2 you want to calculate, right? So X2 by X1 is nothing but root over D is cancelled out, T2 by T1. So your T2 by T1 is, here D is constant, so D1 by D2 it will be cancelled out. T2 by T1 is nothing but X2 by X1 whole square. Very basic. Right? X2 by X1 is what? 2 by 1, 1. So 2 chi square, 4. So T2 is 4 times C1, that is 4000 seconds. Okay, I hope it's asked in seconds. Yeah. So your answer is 4000 seconds. This is very basic question. The Young modulus of quartz piezoelectric. So answer is, I'm just giving answer so that students can easily note it down and see how many marks they are getting. Answer is 1. Okay, let's go ahead. The Young's modulus of quartz piezoelectric crystal is this. So E is given, is 1000 GPa, sorry 100 GPa. The uniaxial stress required to give polarization by 1%. That means delta P by original one. P1 into 100 is given as 1. So what is sigma required? So when you give stress in your crystal, what will happen? You create a strain. That strain elongates the distance between two charges. What is charges? You have a positive charge, you have a plus positive charge, and you have minus charge. Distance between them is D. So you have a dipole. Dipole moment you created is Q into D. Your polarization is dipole moment per unit volume, because with increase in mass or volume, you increase the dipole moment, because more the mass or volume, more plus Q minus Q you will get. The more plus Q minus Q you will get, the more dipole moments you will get. So for unit volume, you'll have a for unit volume, your dipole is nothing but polarization. For V volume, it becomes polarization becomes dipole. You got the point? So polarization is for unit volume. If you multiply by total volume, you'll get a dipole. So dipole is for whole volume. Got the point? But for unit volume, your polarization is exactly dipole moment. Got the point? For 1 meter cube. Okay. How is that possible dimensionally? If you see the dimensionally, P is Q into D, that means Coulomb into meter, and V is meter cube. What is that getting? Coulomb by meter square. Coulomb is charge and meter area. Charge density is nothing but polarization. Right? Surface charge density is nothing but polarization. When the medium is present, if medium is not there, we call it dielectric displacement at vacuum, and dielectric displacement at vacuum and plus polarization together will give you total displacement. Displacement is your surface charge density. I hope you know. What I'm trying to prove here is your capital P is small p. That's it. Your polarization is nothing but dipole moment for unit volume. Remember, P is denoted by capital P into V. Don't forget this. Okay. So when you stretch it, you create a strain. That means, let's say this is plus Q minus Q. So you increase the from D to D1. So your dipole moment or polarization will become Q D to D1. Let's say it is the initial one. Let's say it was D1. After stretching, it becomes D2. So your polarization will become P2 becomes Q into D2. Now, simply I want delta P by P1, right? So I can subtract these two equations. This is equation 1 and this is equation 2. I can subtract P2 minus P1. It means equation 2 minus equation 1. I can do P2 minus P1 is nothing but QD2 minus QD1. That is Q D2 minus T1 equals to P2 minus P1, right? Now, I want delta P by P1, so I can divide by equation 2. I can take this as a 3. So equation 3 divided by 2, right? If you divide, so you get P2 minus P1 by P1. Left hand side divided by left hand side, right hand side divided by right hand side. So Q d2 minus d1 by qt1. See, q is considered. And what is d2 minus d1? Is change in length by original. It is nothing but strain. And delta p by p1 is strain. That means when you stretch your piezoelectric material, okay, you created a strain. At the same time you created polarization. Because of polarization you created electric field, and that polarization must be containing its own electric field or voltage. That means you induce to voltage. If you induce to voltage, you induce current. What have you done? By stretching, you have converted mechanical energy into voltage. That means electrical energy, and that is what the piezoelectric crystals does. Delta p by p1 is epsilon. It's very simple. Now you can do it. Delta p by, okay, something was given. So as you can see here, your E is 100 GPa, sigma is getting asked, and delta p by p1 equals to what? Into 100, 1%. Simple. What is delta p by p1? Epsilon. What is epsilon? Sigma by E. You can substitute simply. You can get sigma equals to delta p by p1 into E. What is delta p by p1? 0.01 into what is E? 100. So you'll get one answer. Sigma equals to 1 GPa. Okay. Answer is